Hello dear students, today we are solving the IIT JAM Geology 2024 paper and we'll start with question number 1. The plate tectonic setting of Benioff Validity Zone is what? So this is actually is also known as the Wadati Benioff Zone. So you can use this name as in alternation. Is a zone of is actually a seismic activity inclined beneath and parallel to the overriding plate in a convergent plate boundary. So where one tectonic plate is being subducted beneath another. So the correct answer is the subduction zone actually here. So option B is the correct answer. When it comes to the other part of the like continental rift refers to the place where actually continent is being pulled apart, leading to the formation of the rift valley. And option C is the passive margin, which is nothing but refers to the transition between the oceanic and the continental lithosphere, that is not an active plate boundary. And the mid-oceanic ridge is a divergent boundary. So it's a divergent boundary where tectonic plates are moving apart, leading to a formation of the new oceanic crust. Okay, so here the BW zone are associated with the convergent boundaries, whereas these plates are moving with respect to one is being the subducted beneath to other. So obviously B is the correct answer. So next is neutron-rich unstable nuclides undergo what? So here and the answer is beta negative negatron decay. So why is that? The neutron rich unstable nuclides have an excess of the neutrons compared to the protons. So to make this makes them unstable because of the strong nuclear force. Okay, this is they're making them unstable. And then the other part is the beta negative decay or the negatron decay is that the process where the neutron molecules decay into protons and an electron particle is into antineutrino. So the process, the increase in the number of protons and decrease in the number of neutrons moving to a nuclear closure is to the value of stability. So beta positive neutron decay here is this part. Now there is a alpha decay. Alpha decay involves the emission of the alpha particles, so decreases both the number of protons and neutrons both. Okay, and electron capture, if we just see, occurs when an all inner shell electron is captured by the nucleus and combining with a proton to form a neutron and releasing a neutrino. So this increases the number of protons and decreases the number of neutrons. So therefore the beta negative decay is the most likely decay mode for the neutron rich one. Okay, so the answer to this question is A. Next one is we move forward to question number 3, and that is which of the following texture is found in the alkali olivine basalt. Okay, so alkali on basalt. So in geology, the texture of the igneous rock refers to the size, shape, and the arrangement of the minerals. So the Rapakivi texture is the type of actually very thick texture found in mostly some granitic rocks characterized by the large orthoclase and the feldspar crystals and all. Then this graphics texture is a type of intergrowth texture where two minerals, often quartz and feldspar, grow together and there's no space between them. And the texture is more commonly found in the granitic rocks rather than the basilistic rock. Okay, so next is the third option is so blastoporphyritic texture is characterized by the large crisps, or rather say just individual crystals and in a finer grain matrix. And the last but the least is intergranular. So intergranular texture refers to the textures where the minerals within the rock are not touching each other. So they are not touching each other. Okay, this is very important, and is commonly found in the basilistic rock. Okay. So based on this description, our answer is the intergranular. So the answer is to this is intergranular. So answer to this question is D, and this looks like this. This is the diagram. Okay. So next is question number 4. The mineral assemblage found in the granite facies. So what will be the approach for this question? Okay, for the metabasalt which is being given. So explanation is the, let's call what is this facies is thing. Okay. So facies is the metamorphic rocks refer to that specific mineral assemblage that develop under the certain pressure and temperature. Okay, so this is the facies part, and then granulite facies is there. Okay, so granulite facies is actually GF. The granulite facies is the facies represents the high temperature around 700 centigrade and 4 K bar. Okay, so typically exceeding this. So the metabasalt is the basalt rock that has undergone metamorphism, transforming its original mineral into new ones under the influence of heat and pressure. Okay, so let's analyze the mineral assemblages in the options. So first is glucophane, lawsonite, and chlorite. These three things. So the assemblage of the characteristics is blue cheese facies, which is high pressure. And the granulite facies part. Okay, so this is not the correct answer. Then there is orthopyroxene with garnet with plagioclase with respect to clinopyroxene and quartz. So this is the correct answer. The assemblage of this classical indicator of this granulate facies metabasalts. And remember that this orthopyroxene and clinopyroxene are stable. This is are stable at high temperature. While this garnet can form under the wide range of pressures and temperatures. So in this case, this is the correct answer. So we don't need to go further. So 4B is the answer.